in this room, I don't think it's actually required that you have two.
Yeah, so you can
Because you
take
can't really show two at the same time.
Yeah.
So I don't know if you want me to take this one
Yeah,
away.
you can take this away.
Okay.
Yeah. Yeah, thank you, sir. Thank you. Hello, guys. Good afternoon. So this is the tutorial session for week 2. As you can see, there are 14 questions on this tutorial sheet. I may not have time to go through all of them. Is it possible to lower this slightly because it's too high? Okay, all right, thank you. So question 1, are you guys okay with question 1? Or you need help? Yeah, anyone has problems with question 1? What about question 2? Question 2, anybody has problems? Hello guys, talk to me. Anybody has problems with question 2?
I don't think the microphone's...
Is it working? Is it not? I think it's on.
Can't see. You'll need to wear this to go into Zoom.
Let me ask them. Can you hear me, guys? Hello?
You'll have to wear that.
Is it?
Yeah.
Okay. Hello guys, can you hear me? Let me know if you can't. All right. So, are you okay with question 1? Okay. Question 2.
Sorry, the podcast is fine.
Okay. All right. Thank you, sir. Thanks for your help. So let's. All right, I'll just do the first part of question 1, if you don't mind. Right. So the derivative of this with respect to x is times the derivative of this, which is all right. So this is the derivative of the Gamble distribution, right? That's question 1. Now the other 2 are similar, so I'm not going to do them. Now let me move on to question 2. Question 2 is to find the mean. Yes.
We cannot see your screen.
Can you see it now? Oh, it's upside down. Come on. Go into filter video settings. Is it this one?
You can check the top one. Yeah.
Top one, this one.
No, the one, that one, uncheck that.
Ah, okay. Thank you, sir. All right. Okay, now. All right, so this is the derivative of the Gumpel distribution, density of the Gumpel, right? Now, let's do question 2. So we want to find the mean of the 3 different types. So starting with type 1, I will just do the thing for type 1. Okay, so this is going to be, because this is defined from minus to plus infinity, going to be x multiplied by like this. Okay, now to do this integration you can do it in different ways, right? Now what I will do is to make a substitution. So set y equal to e minus x, so that means x is equal to minus log of y, so dx by dy is minus 1 over y, right? So put this in a box like this. Now sub this into the integrand, you get x will become minus log of y, then e minus y, dx is minus 1 over y times dy. Okay, and the limits of integration, when x is minus infinity, y is plus infinity, and when x is plus infinity, y is 0. Okay, are you guys with me so far? Let me know if you or including those in the Zoom. If you're not following me, please use the chat room, right? Okay, so the y and the y here cancels, right? And there are 2 minuses, so you get this, correct me if I'm wrong. I hope I'm correct, Now to change the limits around, because it goes from infinity to 0, you want to change it back from 0 to infinity, right? So you introduce a minus sign when you you know that, right? When you change the limit, you need to multiply by minus. Now, one trick, I don't know whether you know, is that if you have, I think I talked about this last week, if you have something like y to the power a, and you're differentiating with respect to a, then this is y to the power a times log of y. I mentioned this last week, right? Do you remember this? Now, if you take on both sides, left and the right, you should set a equal to 0, and if you put a equal to 0 here, which is y to the power 0 times log of y, this is log of y. So let me put this in a box, right? Right, you see what I've done? I put things in a box, right? Now what I'm going to use is so I forgot to mute. What do you mean? Don't understand. All right. Okay, now the next thing I'm going to do is I'm going to replace the log of y here by the left hand side. All right, so this becomes This becomes this, yeah? Now, the next step, I'm going to take the derivative, the operation of derivative outside of the integral, which, I mean, in practice, you cannot do that always, but you have to satisfy some certain conditions. But in this case, I will assume anyway those conditions are satisfied. So, yeah. Oh yeah, you're with me. Now, finally, you may know, familiar with this. I don't know whether you know something called the gamma function. Are you if you're not familiar, I will write it down what it is. A gamma function at alpha is defined as follows. You guys okay? As t power alpha minus 1 e minus t dt. So this is the definition of a gamma function if you don't know it already, right? Now using this definition, you can write the above as d by dA of the gamma function at a plus 1. Okay? So this is simply minus the derivative of the gamma function. I'm using this at 1. Right? So that's the... Are you guys with me? So that's the answer for the mean of the Gumbel distribution. Right? Are you okay with that or not? Right, and similarly you can do the mean for the Frechet and the mean for the Weibull, which I'm not going to do, right? Okay, so let's go back to... Can I take this away? I mean, I will put a scanned version of this on the course website, so there's no... If you cannot copy it right now, you can copy it later on, okay? So we've done question 1, question 2. Question 3 is to find the variances of this, which is similar, so I'm not going to do question 3. All right? You just find the variance. So just like the mean, you find the variance, right? So let's move on to question 4. Question 4 is to show that this is equal to this, if and only if. All right? So let's see how we can do that. So this is question 4. So it says we want to show that okay. Now the lambda is so this is the same as saying that yeah, okay, right? Now this, if you take the nth power of this, what would you get? You will get e minus n times and then if you take the log of both sides, if you take the log on the left hand side and the log on the right hand side, you will get minus n and the minus cancel, so you get n Now the next thing I'm going to do is I'm going to take one more time, I'm going to take the log on the left and the log on the right. Okay? So if I take the log on the left, you get log of n plus the log of this, which is minus x, and the log of the right is minus alpha n x minus beta n. Right? Now what you need to notice is that this is a constant term, this is a term that involves x, this is a term that involves x, and this is a constant term. So for these two to be equal, the constants must be equal. So in other words, the constant on the left hand side is log of n. The constant on the right hand side is minus beta n. Right? And the coefficient of x on the left hand side is minus 1. And the coefficient of x on the right hand side is minus alpha n. Right? So what we have shown is that beta n is equal to minus log n, and alpha n is equal to 1. Okay? So that's the question, I believe. Is that right? Yeah. So that's how you will do it. Okay? Any questions, guys? Are you okay with that? All right. Good. So that's question 4. We are done. So question 5 is similar. Question 6 is also similar. Question 7, I think I did this as an example in the class. If you look at the video, I'm sure you guys watched the video, right? I think this is one of the examples I did in the video, right? So I'll move on to question 8. Now, by the way, this term, max domain of attraction, when I say, I know some of you asked me this question, the max domain of attraction means basically asking you which of the 3 types holds. Like, so if type 1 holds, then you say that the distribution belongs to the Gumbel domain of attraction. If type 2 holds, then you say that the distribution belongs to the Frechet domain of attraction. And if type 3 holds, then you say that the distribution belongs to the Weibel domain of attraction. All right? So in this case, we want to find the domain of attraction for this guy here. So let's see how we can do it. So it's question 8. So you have f of x equal to power alpha, where x is positive, right? Now the first thing you must find out is the w of f. So you set fx equal to 1, which implies that it's equal to 1. This implies that this is equal to 1, and this implies that minus ex is equal to 0. So e of minus x is 0. So x must be plus infinity. Now the reason, so you follow me, right? So what we have shown is that w of f is equal to plus infinity. It's kind of clear from the question, because if you look at the support of the distribution, which says that x is positive, so the largest point of the domain of the CDF must be plus infinity. So that's your upper end point, w of f, right? All right. So let's check condition 1. Condition 1 says that the limit as t approaches infinity just give a shout if you can't follow. Give me a shout. Hello, you're right. Okay, so this is what you get. Now, one formula, I don't know whether you know this from your math courses that you have taken. Do you guys know this result? That if you have something like 1 minus z to the power alpha, it behaves like 1 minus alpha times z if z approaches 0. Do you know this or not? This is, I mean, it's a basic result. You might know this or you might not. If you don't know this, try to remember this, okay? Okay? Now, as you can see, as t goes to infinity, this guy goes to 0, right? And so is this one. This also goes to 0 as t goes to infinity. So we can use this result here. You follow what I'm saying? Yeah? Because in order to use this result, you need to make sure that this term here, z, approaches 0, right? Which is the case here, right? Alright, so using this result, you can see okay, this is what you get, right? Now the 1 and the 1 cancel, the 1 and the 1 cancel, so you get, this is the limit as t approaches infinity of alpha okay. Now the alpha and the alpha cancel, so this becomes the limit as t goes to infinity and of e of minus x gamma of t. Alright? And this is equal to e of minus x if you choose gamma of t to be identically equal to 1. Okay? Right? So remember the type 1 condition says that the limit must be equal to e of minus x, right? And so therefore the condition for type 1 holds. So the conclusion is that f belongs to the Gumbel domain of attraction. Is it all clear to you guys or not? So, are you guys okay?
Yeah.
Yeah, alright. So we are doing question 8, which you just came. We are doing question 8 of the week 2 tutorial sheet. Alright. Any questions, guys? All of you okay, guys?
Just full screen is in. Just full screen is in.
Sorry, I can't hear you.
You like maximize, make it bigger.
Make it bigger.
Yes.
This one? I don't know. I have no idea. Well, you mean like this?
Yeah.
Like this? Okay. All right. Thank you. Any other questions, guys? You okay? Yeah. All right. So let's go to the next. So we're done with 8. Question 9 is something that I did in the videos. So I'm not going to go through that. This is something I did in the videos. All right. If you watch the videos, you will know the solution. So let's look at question 10. Question 10.
There we go.
Question 10 is, you have fx equal to 1 minus k divided by x power a. You should say x is greater than k, although the question doesn't say that. Right, the first thing you need to figure out is what is w of x, right? So you put f of x equal to 1, right? Which implies that 1 minus is equal to 1. Yeah? So the 1 and the 1 cancels, so this implies that it's equal to 0. Yeah? So it's equal to 0. So x must be plus infinity. So w of f is plus infinity. Right? Right. Now let's start with condition 1. Right? So for condition 1 to hold, yeah. Right? Now clearly these two guys cancel out. Okay? So what you have is, I'm doing it slowly, but I mean I could do this in one step if you want me to, but just I'm doing it slowly just for the benefit of you guys. Right, so let me do this slowly. Right? Now the k in the top and the k in the bottom cancel out, right? So what you have is right? Okay, now the question is, for the condition 1 to hold, this guy must be equal to e of minus x, right? Do you think it can be equal to e of minus x? Yes, so I mean, there's no chance. It doesn't matter what you choose, gamma or t, to be, there's only one x here, right, in the bottom. Right, so there's no chance this is gonna be equal to, right? So that means the f cannot belong to the coupled domain of attraction. So let's go to the condition 2. So we're gonna check condition 2. Remember, condition 2 says the following, is the limit as t goes to infinity of this, right? So this is gonna be limit like this, alright? So once again, the 1 and the 1's cancel. So what you have is the limit as t goes to infinity of yeah. Now the k and the k cancel, and the t cancel. So what you have is that this is equal to x to the power minus a, right? And hence condition 2 is satisfied. Right? Remember the condition, yes?
Would you want us to check the conditions in like sequential order and then that? Because for a condition like that, then there's no exponential to them, so you can sort of rule out condition 1 straight away. Can you just check condition 2 first and then?
Yeah, you can do that like that. Yeah, you can. Yes. The answer is yes. All right. So the conclusion is that f belongs to the Fréchet domain of attraction. All right. Are you guys okay with this or not? Anyone on Zoom has a question? All right. So that's question 10. We are done. Now question 11 and 12 are a little bit tricky, but I will show you. There is a detailed solution of 11 and 12 on the course website. I can show you like how to do a part of it. So let me show you. So question 11 is basically about the two questions. It's asking you to, it gives you an expression for f in terms of g, right? Where both f and g are cumulative distribution functions. And it's asking you to show that both f and g belong to the same max domain of attraction. Now, when you get a question like this, you will get a question like this in the exam, and possibly also in the in-class test. So when you get a question like this, what you need to do is the following, right? So you have you need to do three things, right? Number one, assume G Yeah. So the first thing you need to show is that assume that G belongs to the Gumbel domain of attraction. So that's abbreviation, okay, for domain of attraction, and show that F also belongs to the Gumbel domain of attraction. That's the first thing you need to show. The second thing you need to show This is the second thing you need to show. So assume that G belongs to the Frechet domain of attraction and show that F also belongs to the Frechet domain of attraction. And the third thing you need to show is to assume all right, so every time that you get a question like this, you need to show these three things, right? Number one, you need to assume that G belongs to the Gumbel domain and domain of attraction and show that F also. Number two, assume that G belongs to the Frechet domain of attraction and show that F also. And number three, assume that G belongs to the Weibel domain of attraction and show that F also. Right? Now I'll show you in the time I have, hopefully, I'll show you just, provided that I get enough time. Let me show you how to do part one. So part one, I'm going to assume that G belongs to the Gumbel domain of attraction, right? Which means the following. That is, there exists a function gamma of t such that the following is true. That is 1 minus g of t plus x gamma of t divided by right. So let me call this star. We need this letter, right? Now what we need to show, we are assuming this is true. What we need to show is that we need to show that the limit as t approaches w of f of 1 minus f t plus x gamma of t right, we need to show that this is of the same type as this, right? So to do this, the first thing I'm going to do is I'm going to use the L'Hopital's rule, right? Because as you know, since t approaches the upper end point of f, both these approach 1 minus 1, 1 minus 1, which is 0 divided by 0. So hence you can use the L'Hopital's rule, right? So this becomes yeah, sure.
Why is the derivative of t plus x
Yes.
gamma t to be 1 plus x? Is an x a derivating
X is fixed map, Veronica. So we are differentiating with respect to t.
t?
Yeah.
Isn't t is an x a constant, and that would be removed from it?
X is a constant. X does not depend on t. X is fixed.
So the derivative, for example, from at when B only counts and
Yeah.
yeah.
All right. Yeah. Okay, guys. Any other questions? You all right? All right. In the next step, what I'm going to do is I'm going to put, because if you look at the question, guys, this is the question says that f of x is equal to this, right? So I'm going to, at the same time, I'm going to replace this guy here by w of g, because that is allowed. According to the question says, you can assume that w of f is equal to w of g. So I'm going to replace by that. And then, are you guys okay? All right, now I'm going to replace this guy here by k. Right, and then I'm running out of space here, so it's going to be E minus C okay, like this, right? I'm sorry for not writing it clearly. Then in the bottom, and also you need to multiply by this term here, which I left out, 1 plus. Right, in the bottom you have k right? Do you follow my writing or not? Muhammad, yeah. The reason I'm using the L'Hopital's rule is because, my friend, this as t goes to the upper end point of f, this goes to 1, and so is this one, right? So you have 1 minus 1 divided by 1 minus 1, meaning 0 divided by 0. So hence you can use the L'Hopital's rule. Is that clear, Muhammad, or no? Or no?
Is that given in the question that f?
Huh?
Is that given in the question that f approaches 1?
Yeah, it's because it's a CDF. A CDF must approach 1 as t approaches the upper end point. That's by definition, right? Yeah. So both this guy here and this guy here must approach 1 by definition. Some of you look lost. Come on, guys. Because a property of a CDF or cumulative distribution function is that it must approach 1 when it reaches the end point, right? Remember that if you plot f of t versus t, right? Normally it looks something like this. So this is the point it approaches 1. This is the point it approaches 0, this way. So if you go far enough to infinity, the CDF must approach 1. Have you seen this picture before? I'm sure you have. A long time ago, somewhere. Yeah. All right. So that's the theory, guys. Okay. All right. Anyway, so the k and the k cancels. So you have limit. Let me know if I run out of time. I'm not sure. We have limit of now I'm going to combine these two. So right? Now I'm going to combine these two guys too, so you get sorry for my dirty writing here. If you combine the two exponential terms, you have e of, there should be a c here in the top, e of c g of t and then finally you have the 1 plus x gamma prime of t. All right? I hope this is clearer than this one. All right. Now, as t goes to the upper end point for g, does this work? Oh, here you go. As t goes to the upper end point for g, this guy here, by the same argument, this must approach 1. And so is this one. This also approaches 1. And so is this one. Approaches 1. And so is this one. This approaches 1. Can you see that?
That's also just G is a valid CDF, right?
Yeah, we are assuming G is a valid CDF parameter. Yeah, we are assuming that both F and G are valid CDFs. Yeah. All right. Now, so this is 1 divided by 1 is 1. This is c minus c is 0. So e of 0 is 1. So what you have is the limit yeah. Right? All right, so it's a lot simpler now. Right? Now, you should go back to star. Remember, this is star. I zoomed earlier, right? The limit of this is equal to e of minus x. So using star, just bear with me. If I run out of time, I'm sorry. Using star, what you have is just give me a sec, guys. That this guy here is equal to e of minus x to the power b minus 1, right? Yes, I will upload it to Blackboard. To my course website after the tutorial. Yeah, so don't worry, my friend. I will upload a scanned version of this to my course website. Okay. So this is equal to e of minus b minus 1 times x times the limit as t goes to infinity of sorry guys, I'm sorry I'm running out of time, but just bear with me for a second. Now I'm going to use L'Hopital's rules one more time, but backwards. If you use the L'Hopital's rule backwards, this is what you will get. So this, by the way, this should say not infinity, W of g. This should be W of g. Do you see what I've done here? Guys, what I have done is to use the L'Hopital's rule not from this step to this step. Now you should differentiate the top and the bottom with respect to t you will get exactly what you have here. Yes,
You just choose the constant part.
that's a constant, yeah. I've taken it outside.
No, I mean like in the inside limit. You
Yeah.
can choose any constant. You just choose one.
Yeah, you can, yeah. Yeah. So you see, I applied the L'Hopital's rule in the backward direction. Now this, by star, one more time, by star, right, the limit of this is equal to, is this, and this is E of minus Bx, which is of the same type, as E of minus x. So hence, finally I'm done, hence f also belongs to the Gumbel domain of attraction. Right now it looks complicated, but if you done enough examples, I mean there are plenty of examples like this. There are plenty of examples like this on the course website. So you do, I mean, every past paper contains a question like this, right? I think there are last 7 or 8 past papers you can look at. Every one of them has a question like this. So if you practice them, you'll find it, routine. Yeah, any questions, guys? Yes.
On the midterm that's coming up, he said, I think that we have both, like in-person exam for people in person and online for people online.
Yeah, but that's what I said, but I may change my mind. If everybody is here, then I may have it like in class, or if everybody is not here, then I will have it just online.
Yeah, that's what everybody.
Yeah, that's what I know.
Together.
Yeah, one or the other, not both. I think that's the best way to do it. Yeah. I heard, like, I don't know, I'm not sure whether everybody will be here or not, but we will see. Huh? Yeah, final week of semester 1, yeah. You have a question, Veronica?
Are you talking about the final exam or just the in-class test?
No, just the in-class test. Yeah. The final exam will be on campus, as you know. Yeah. Any questions, guys? Any other questions? You guys over there, are you okay? Yes. Okay. All right. Just any questions on the? I will put a scanned version of what I have written. Well, thank you, Veronica, for the paper. I forgot to bring my papers today. Don't know why. So I'll see you guys shortly next week. But if you have more questions, feel free to contact me 24/7, as usual. Right? Thank you, guys. Thank you.
Thank you, sir.
Yeah.
See you, sir. See you next.
See you. Have a good weekend.
You too.
Yeah.